Good morning, teacher. We are Group 4, class CC01 of Calculus for Business. This is a group project. The topic is area of one Vietnamese province. This is member list. Firstly, let's talk about introduction. Numerical integration can have to calculate the area that is limited by one or several functions. Firstly, let's begin with a general introduction of this tool of numerical integration. If fx is continuous on the interval a, b, then the area limited by fx for x equal a to x equal b is equal to like this. So we have an overall formula. Regarding to the area limited by two functions fx and gx, we have a similar overall formula.
Hello, Mr. Long. I'm Dr. and I will undertake the part of calculate the area of Benin province. So the first part I will use using the quadratic equation for three consecutive points. I will divide the area of Benin province into 2 points. The first one is here, and from 3 point A, B, C, I have the fx new function fx is equal to 5 over 2x a squared minus a over 5, and the area s1 will equal to uh, minus anti Hello, Mr. Long, and I will undertake the part of calculate the area of the new province. Firstly, I will using the quadratic equation from three consecutive points. The first one, I should. Hello, Mr. Long, and now I will this is I will calculate. Hello, Mr. Long. Hello, Mr. Long. I'm Dek and will undertake the part of calculate area of the new province. The first, I will using the quadratic equation from three consecutive points. I will divide this area into two parts. The first is S1. The S1 is equal to equal to minus from you can see here S1 is equal to 1.71. And the S2 I will use two kind of function, the linear function, two linear function, and one quadratic function. So I have with point D and E, I have a linear function fx. E, F, and G, we have a linear function gx, and 3 point A, B, C, I have a quadratic function xh. Finally, I got the p y is equal to minus 1.1. And here is my graph about this. So I find the similar point that the intersect point of each function and with OX and OE. So we have x2 is equal to like this. So you can see I will use the area of the triangle too, and also with the area the function I have learned. And when I use the trapezoid rule, I have another question, have another result. The S1 will equal to 0.84 and S2 will equal to 2.04, and the overall The overall area was 2.88, and the realistic area of the marines is 6,851 kilometers square. However, my calculation of attractive function was only 4,520 kilometers square, and trapezoidal was only 2,000 and 2,040 kilometers square. This is a big difference between reality and calculation by theory. Thank you for your listening.
And next, we will introduce some useful methods to approximate definite integrals and examples. First, approximation by rectangles with midpoint rule. This method is based on the area of rectangles found under the fx curve. So, suppose the function fx is continuous in a to b, where n number of rectangles with equal step h are formed under the fx, and fx star is intersect at the midpoint of the rectangle. Then we have this function, and with h here is equal to b minus a over n, and xi star equal to 1 over 2 multiplied by xi minus 1 plus xi. Here an example. Use the midpoint rule with 3 subintervals to compute the integral from 1 to 3 of x squared dx. Now, we have a equal to 1, b equal to 3, so there are two rectangles here. And we have h equal to b minus a over n, so h is 1. And we will find f is 1 star, f is 2 star, and f is n star with I equal to 1. So xi is 1 and xi star is 0.5. Use this function. So we have f is 1 star equal to 0.25. Similarly, with I equal to 2, f is 2 star equal to 2.25, and when R is 3, f is 3 star is 6.25. Now we have all number, and so the integral from 1 to 3 of x2 dx, and we use the calculator, we will have 8.75.
Hello everyone, my name is Tan, and my session is approximation by trapezoids. To be, this method is based on the area of trapezoid which formed under the curve of fx over the interval a to b. As you can see on the paragraph here, suppose that the function fx is continuous in a where n number of trapezoidal with equal step size h are formed under the fx, that we have the formula here. Example, trapezoid rule with 3 subintervals. We have A and B, so we have H. As you can see here, based on the formula, this is the result. The result of the example is 130.
Okay, we will come to the next part, the approximation using parabolas, which we call the Simpson rules. This method is based on the area under the parabola shape of the fx over. We'll come to we'll come to this part. Suppose the function fx is continuous in for a to b, where n number of subinterval with equal step size h. Then we have the formation integral from a to b of fx dx is approximate h above 3 of the expression of fa, which here plus 4 multiplied by the summaries of fxr plus 2 multiplied by the summaries of fx even plus fb, where we can have fa is equal to fx0, fb is equal to fxn. Also, we can have x odd is equal to x1, x3, and x5, and x even is x2, x4, and x6. We will come to an example to understand more. We will use the Simpson rules with 4 subintervals to solve the problems. The integral from 4 to 5 of square root x cubed plus 2 times x squared plus 3 times x plus 1 dx. As we can see, a is equal to 4, b is equal to 5, so we can find out h is equal to 0.5, and after that we can create, and after find out all the fxi we need, we'll come to the last part is calculating. We will use the formation above here. Yes, we can see we'll have approximate h. We already have the number for all the x, so we can find out the number for this. The solution for this equation is approximate 5.45 or 47. Sorry.